Welcome to the Math Tracker. Today I'll be covering the ICTM Regional 2015 Division A Algebra 2. Okay, number one. Okay, to add matrices, all you have to do is basically add everything on one side is equal to everything on the other side. So the 2 plus 6 is 8, the 1 plus 9 is 10, the 5 plus negative 3 is 2, right? So that means the 6 plus k is equal to 17, so k is 11. So you do the same thing with w and p. So w is equal to 6, because 6 minus 2 is 4, and p is equal to negative 10, because negative 10 plus 3 is negative 7. So the negative 10 cancels out with the 11 to make 1, so 6 plus 1 is 7. So that's your answer. Number 1, 7. Okay, let's erase this. Okay. Number 2, determine the maximum value of the function f of x is equal to 2x squared minus 16x minus 25. Okay, so you could do this both ways. You could complete the square, or you could use negative b over 2a. So if we're completing the square, we have negative 2. And then that's x squared minus 8x plus some kind of number. I really don't want to care this much. All you need to know is you just need to divide by 2 from the second one. So that makes it plus 8 actually. So if this is a plus 8, we got to take half of that, so that's plus 2. So that's negative, plus 4. So negative 2x plus 4, and then you square it. So that makes the x squared. That's negative 2x squared. That's a plus 8, so that's negative 16x. And then this one would be plus 16. That makes negative 32. So we had negative 32 in the end, but we need to get negative 25, so we have to add a 7. So that means our answer is 7 because that's our maximum value. And that's basically how you do it, completing the square really fast. Another way to do it is you could use negative b over 2a. So negative, or b is negative 16 over 2a is negative 4. So this is equal to negative 4, right? Negative 16 divided by negative 4 is 4 times negative 1 is negative 4, right? You can plug that in. So into x, so that's negative 2 times 16, so that's negative 32, plus 64 minus 25. So that's 32 minus 25 is equal to 7. And that's another way to do it. Number 3, determine the value of k so that 3x squared minus 6x plus k is equal to 12. So basically 3x squared minus 6x plus k minus 12 in parentheses. So you gotta make a quadratic. So when it has exactly one double root, what it's basically saying is that it's something like this, ax plus b squared, right? And then it's equal to this entire thing. So what we had to do is we had to take the square root of the coefficient. So that's 3. So square root of 3. And that will be in front of that will be the a. So we need to find our b. So plus b squared. So that would be 3x squared if we were expanding this out plus 2 square root 3b x plus b squared. So this is equal to 3x squared is equal to 3x squared. So 2 square root 3 b is equal to negative 6. So that means b has to be negative square root 3. That means this term over here has to be equal to just 3. So 3 is equal, because this term has to equal to this, is equal to k minus 12. That means k has to equal to 15, and that's your answer. Okay, just a bit of arithmetic. Number 4, determine the number of distinct positive integral factors for the number 635,040. So 635040. So when it says integral, it means it has to be an integer. So it has to be like 1, 2, 3, 4, etc., right? So what we have to do is that we're going to have to factor this. So you use your calculator. If you not use your calculator, depending on what it is, it might be able to just factor it fully. But if you cannot, just start factoring by what you know. So we can factor by 10 because it ends in 0. So that's a 2 and a 5. So 2 times 5 times. So you just divide by 10 in your calculator, and it should be pretty obvious. It's 63504. Right? And this could be factored out with another 2 because that's even. So that's 31752 divided by another 2. And I see that there's another 2. So 7938. Just keep on whittling it down. And then that makes another 2. And it could then be divided by 3. So times 3 times 1323. Is it divisible by 3? Yep, it's divisible by 3 again. And divisible by another 3. and a 3, and 2 7s. Okay, so we have 1, 2, 3, 4, 5. We have 5 2s. And we have 1, 2, 3, 4, and yeah, we only have 4 3s. We have 1 5 and 2 7s. And you can like plug this in your calculator to check if it's the actual factor form. Okay, so it is. So what we're gonna do is that I'm gonna make the exponent for 5 1, right? Because it is. And all you have to do now is that you're just gonna add the exponents. I mean, add 1 to every single exponent. So 5 plus 1 is 6. 4 plus 1 is 5. 1 plus 1 is 2. 2 plus 1 is 3. And you gotta multiply all these numbers together. So 6 times 5 times 2 times 3. And that is 180. And that should be your entire answer. That should be your answer. So to find the positive integral factors, so the positive factors, so basically just have to be integers because they're factors by definition, then basically all you have to do is that you just have to pi and factorize everything, add 1 to each of the exponents and multiply them. And it's gonna get you the answer. That's like I'm not sure if it's a theorem, but it's something that you could use every single time in a math competition. It'll always work. And if you want to look for not just the positive and negative, you just multiply 2 because every single positive has a negative. Number 5. Um, basically f of g of x is equal to f, where g of x is inside f of x. So f of x is equal to fx plus 2, and g of x is equal to gx minus 2. Find f of g of 4. So we have to find g of 4 first. So 6 times 4 minus 2, that's 24, that's 22. So we just had to find f of 22, which is just 88 plus 12, which is equal to 100. And that's your answer for number 5. Basically just that simple. Number 6, determine all real values for x such that the cube root of 2x plus 7 is equal to 3. So 2x plus 7 is equal to, what's 3 to the power of 3, right? So 2x plus 7 is equal to 27. So 2x is equal to 20, x is equal to 10. So the only possible answer is 10. Because if you're taking a cube root or something, if you're taking like a square root or a fourth root or a sixth root, like anything with the even root, there might be a positive or negative. But if it's an odd root, there's only one possible answer usually. So all real answers, the answer is just 10. The average of two numbers is 36, so let's use two numbers, x and plus y. Average is 36, so divide by 2 is equal to 36, so that's add up to 72. The geometric mean is 15. So if you x times y, take the square root, that's 15. So that means x times y is equal to 255. The x times y is 225. Determine the exact absolute value of the difference of these two numbers. So we had to find x minus y, right? We need to find this difference. So all we had to do is basically use x minus y squared, which is basically equal to x plus y squared. Because if you expand this out, this is 2x squared minus plus y squared minus 2xy. And this is equal to x squared plus y squared plus 2xy. Right, so this is a minus 2xy and this is plus 2xy. So to make this the same, you got minus a 4xy on the side. Okay, so we know that's true. Can't delete all this because we don't need it. Okay, so we know this equation is going to be true. So instead of finding what xy is, we're just going to use this equation. So we know x plus y is, that's 72. So 72 squared, let's put parentheses around it, minus 4xy, we know what xy is, that's 225. And that is equal to x minus y squared. So using our calculator, 72 times 72 minus 4 times 225, we get 4284. And that's x minus y squared. Right? So that means x minus y, which is what we're looking for, the absolute value of the difference. Because it doesn't matter, it's going to only take this positive. So 4 to 84. So that if you kind of have to factor this out, it's going to be 2 to the 2 times 3 times 2 times 7 times 17. So technically, you're just going to take the square root of this. So 2 times 3 is 6. So that's equal to 6. And then the 7 and 17 is still inside the square root. So that is 119. Multiply them together. So your answer is 6 square root 119. And that's basically it. Number 8, two of the zeros for f of x, x to the power 4 minus 7x cubed minus 53x squared plus 265x minus 350 are integers, and the other two are complex numbers of the form k plus or minus wi, where I is equal to square root negative 1, so it's just a complex number. That's basically what it is. And w is positive. Okay. So basically, if you want to find the zeros, you could just do a graphing. If you have you're using a calculator for a contest, because this is allowed, you could basically just plug in the equation into your graphing and then find the zeros. So x to the power 4 minus 7x cubed minus 53x squared plus 265x minus 350. Okay, so basically, we're just gonna use our calculator to find the zeros because there's gonna be two. Because since this is x to the power 4 and they told us there are two of the zeros are integers, that means the other two has to be the complex numbers because it's raised to the power 4. So 2 plus 2 is 4, right? So we want to find out what the zeros are, so using your calculator. We find out one of the zeros is negative 7, and the other zero is 10. Okay, so the other zero is 10. Okay, so using our graph. Or if you have like a pretty good calculator, I'm not sure which types have it, but I know for sure that the TI Nspire, which is the one I'm using, could have a polynomial solver which gives you all the roots. So that's a really good calculator to use if you're doing for contests. So since we know these two are zeros, all we have to do is just factor it out. So x plus 7 and x minus 10. Okay, so we know we could factor that out because we have like x minus like a number and then x minus some other number, but they're both complex, so they're not really factorable. So it's more like a squared, um, a ax plus b, right? So then we know x squared minus 3x minus 70. Okay, multiplied by some number is equal to by some polynomial is equal to this polynomial. So we know that other polynomial has to be x squared. So we can have a 3x squared. That's a 7x. I mean 3x cubed. This is 7x cubed, so this has to be a minus 4. And this is a negative 70. So we need to get a negative 350. So this one's a plus 5, right? So x squared minus 4x plus 5 is equal to the equation that we need to find for a complex. So we know this equation is true. So let's kind of move this up. So we just need to find the root for these equations, which we just use the quadratic formula. So all you have to do is basically, if you want to complete the square, which is usually what I do. So this is x minus 2, x squared minus 4x plus 4. So you have to plus 1. So that's equal to 0. So x minus 1 squared is equal to negative 1. Take the square root of both sides. So take the square root of this. So x minus 1 is equal, x minus 2 is equal to plus or minus I, right? Because square root of negative 1 is I. So x is equal to 2 plus or minus I. So that means our ordered pair for our answer, because w has to be positive, is going to be 2, comma 1. Because the coefficient for this one's 1. So that's our answer. Okay, if you have to do it by hand. You have your calculator, just plug in everything in your calculator. Determine the exact distance from the center of the circle given by this is equal to the vertex of this. So the you don't have to solve for the what the center of the circle is. All you need to know is that you have to find the x and the y. So in front of the x is the 8. So 8 divided by 2 is 4, and you have to take the negative of that. So that's negative 4. Okay. So in front of the y is a negative 6. Negative 6 divided by 2 is negative 3. Take the negative of that, that's 3. So that's our center for our circle. Okay, the vertex of our parabola is basically going to be, well, we're just going to have to factor it out. So x, oops, that looks kind of bad. X squared plus 4x plus 3. So that's x plus 2 squared. So that's x squared plus 4x plus 4. So that's minus 1. So our coordinates at negative 2, negative 1. Okay, let's delete this because we don't need it anymore. Okay, so to find the distance, negative 4 to negative 2 is 2, so that's 2 squared. 3 to negative 1 is 4, so that's 4 squared. That's 4, and that's 16, so that's 20. So take the square root, that's our distance, and that is 2 squared root 5, and that's your answer. Question 10. Given that g of x is equal to 6 to the power 0.6x, determine inverse of g of 36. So if it's inverse, basically what it means is that that value, that 36 is equal to the y. So that means 36 is equal to 6, 0.6 to the power of x. So 36 is 6 squared, so 6, 0.6 to the power of x. That means 2 is 0.6x. So that means 2, 0.6 is just 3 over 5, so that's just 5 over 3. So that equals 10 over 3, and that's your answer. And that's basically it, just a bit of arithmetic. Okay, let's erase that. Number 11, determine the order pair xyz that is a solution to system equations. X plus y minus z is equal to negative 1, 4x minus 3y plus 2z is equal to 16, 2x minus 2y minus 3z is equal to 5. So all you have to do, if you have a calculator, as I said before, you just plug it into your calculator as a matrix and then solve it. But if you want to do it by hand, basically what we could do is that we could cancel out one variable and then work with two of the others. So I see that the z right here is kind of pretty nice because there's a 1 here. Coefficient is 1 and then there's a 2 and then 3. So we could just cancel each other out by scaling the first equation. So we had to cancel out the first and the second by itself. We just multiply the first one by 2. So 2x plus 2y minus 2z is equal to negative 2. So we have 4x plus, for the second equation, we have 4x minus 3y plus 2z is equal to 16. So adding them together, that means 6x minus y is equal to 14. Okay, so now let's use the first equation and the third equation. So multiply the first equation by negative 3. So that's negative 3x minus 3y plus 3z is equal to 3. 2x, this is the third equation, minus 2y minus 3z is equal to 5. I usually like to add, so I use process of elimination. So I don't substitute ever. And then negative x, and then minus 5y is equal to 8. So the reason I like to use elimination is that it kind of works faster. Well, in what I see usually from contests. Substitution, use it when it's necessary, but I usually like elimination because it works pretty quickly. So we have these two equations. Okay, so we just have x and y. So I see that this one is just negative 1x, so let's multiply this by 6. Get negative 6x minus 30y is equal to 48. Adding that together, that's negative 31y is equal to 62. That means y is equal to negative 2. So if y is equal to negative 2, we just plug into one of these equations. So let's say this one. So y is negative 2, that means 6x is equal to 12. That means x is equal to 2. So our x is 2, our y is negative 2. So that means if we plug into first equation on number 11, as you look back at the question, right? 2 plus negative 2, that's 0. So that means z has to equal to 1, right? So our answer is 2, negative 2, negative 1. Okay, and that's our answer. Okay. Number 12, f of x is a linear function and g of x is a quadratic function. Okay, so let's kind of write that down. So f of x is a linear, so ax plus b. And g of x is a quadratic function. So that's actually, let's not use a, because we already used that. Cx squared plus dx plus e, right? If you plug in g of x into f, you get x squared plus 1. So that means basically, and we see that g of f of, put f of x in g of x, your coefficient is also 1, because in front of the x squared is 1. So that basically tells us that this and this does not exist because they're both going to be 1 regardless if you plug it in. So you plug in f of x into g of x, you get x plus b squared plus d x plus b plus e is equal to x squared plus 4x plus 3. And if we plug in g of x into our f of x, so that's x squared plus dx plus e plus b, we get that is equal to x squared plus 1. So we know that since there's no x term, that means this has to equal to 0. So our d has to equal to 0. So based on that, we could rewrite this as x squared plus like e. Okay, so let's go ahead and delete the entire thing because we just simplify it like that. So let's make this a little nicer. So f of x is equal to x plus b, and g of x is equal to x squared plus e. Okay, for that. Okay, so that's an x. So if we plug in x squared plus b plus e, right, g of x into f of x, that means b plus e has to equal to 1. So b plus e is equal to 1. And we plug in f of x into g of x, that's x squared plus 2bx plus b squared plus e. That has to be equal to our x squared plus 4x plus 3. So b has to be equal to 2 because that has to be equal to 4. So b is equal to 2. So if b is equal to 2, that means e has equal to negative 1, which makes sense because this one has to this entire thing has equal to 3. So that's 4 minus 1, that's 3. Okay, so find the value of f of negative f of 1. So f, we know that b right here is 2. So f of 1, plug it in, that's 3. So our answer for number 12 is just 3. Okay, number 13. 2 to the power negative 1 plus 2 to the power negative 3 over 2 to the power negative 2 minus 2 to the power negative 4 is equal to k over w. So find k over w. Find k plus w. Okay, so that's 1 half plus 2 to the power 3 is 8. So that's 1/8 over 1/4 minus 1/16. So we could kind of add this together. So that's 4 over 8. So that's 5 over 8 on the top. And this is 4 over 16. So this is 3 over 16. So 5 over 8 times 16 over 3, right? Dividing by a fraction is multiplying by its inverse, 2. So that's equal to 10 over 3, right? So our answer for number 13, wait, sorry. Our k is 10 and our w is 3, so adding them together is 13. Sorry about that. Okay. So number 13's answer is 13. Question 14. Given the x squared plus 1 over x squared is equal to 3, the largest solution for x can be written as reduced and simplified k plus w squared p over q. And they're all integers, and find the sum of all those numbers. Okay, so basically we have to find what x is and then like sum everything up basically. So x squared plus 1 over x squared is equal to 3. So write it as a basically like a quadratic. So multiply both sides by x squared. So that's x fourth plus 1 is equal to 3x squared. So x fourth minus 3x squared plus 1 is equal to 0. Okay, so we know that's true. So leave this apart because we don't need it anymore. Okay, so we have this. So if you kind of think about this like a quadratic, right? Because let's say a is equal to x squared, right? We substitute a squared minus 3x plus 1 is equal to 0. I mean, 3a. Sorry about that. So a squared minus 3a plus 1, right? So it's like a quadratic. So it's a equals negative b plus or minus over 2a, right? So basically all we have to do, instead of saying that's a, because substituting, which is like a couple extra steps, all we have to do is say it's x squared. Say instead of it being x is equal to that, it's x squared because that's the square root of x4. So x squared is equal to negative b, so 3, plus or minus b squared, which is 9, minus 4ac, which is 4, over 2a. Okay, so that simplifies to 3 plus or minus square root 5 over 2. Since they said they want the largest solution for number 14, that means x squared has to be 3 plus square root 5 over 2. The reason is you can't have a minus is because 3 minus square root 5 will make it smaller. 3 plus square root 5 will make it bigger. So since you're trying to look for the largest, you're going to have to think about it logically and say that it has to be a plus. Okay, so now that we know what x squared is equal to, let's kind of delete this. We just need to find what x is equal to now. So we have x squared is equal to this. So that means our x has to equal to the square root of that entire thing. So 3 plus square root 5 over 2. So this is the correct answer, but it's not the right answer because it's not in the correct form, right? So um, competitions don't like having radicals nested inside radicals. They don't like radicals inside radicals, basically. So all you have to do is that you kind of had to like simplify this. So that's the same thing as saying 3 plus square root 5 over square root 2. So we have to multiply the top and bottom by square root 2. So that is equal to square root 6 plus 2 square root 5 over 2. Okay, so now you gotta think about this. How do we take a square root of this? So if you think about a plus square root b squared as equal to 6 plus 2 square root 5, right? Then if you take the square root of that and you take the square of this, then the answer is just a plus square root b, right? It's just right here. Squared square root, so it's just a plus square root b. So now we just need to find out what that is equal to, right? We need to find out where our a and b is. So if you expand this out, that's a squared plus 2a square root b, oops, square root b, 2a square root b plus b is equal to 6 plus 2 square root 5. So that means a squared plus b is equal to 6, and 2a square root b is equal to 2 square root 5. So we cancel out this 2, so we know a square root b is equal to square root 5. So we know that's true. Okay, so let's delete this, this. Okay, and let's move this up. A little bit more room to work with. So you gotta remember it's a plus square root b. That's what we're looking for. So we know if we kind of make this all inside a radical, so that's a squared b is equal to 5, right? Because square root, right? So a squared times b is equal to 5. So we know that's true. And we know what and we could just substitute this a squared into this a squared. So all we have to do is just say 6 minus b times b is equal to 5, right? So what number would make that come true? We have a negative b squared plus 6b is equal to 5. Just gotta take this out because we don't need it technically. We just need to simplify this part. Okay, so that's b squared minus 6b. Move this to the other side, so that's a plus 5 is equal to 0. So that means it's b minus 1 and b minus 5 is equal to 0, right? Because b squared minus 5 minus 1 minus 6 together, so that's plus 5, okay? So b is 1 or b is 5. So it kind of doesn't matter which one's which, because technically it's all gonna come back the same. So if b is 1, right, we'll plug it back here. That means a is equal to square root 5, so, right? It could be plus or minus square root 5, but since you want the bigger number, you're gonna make it positive. So, um, and if your b is equal to 5, right, b is 5, so 6 minus 5 is 1, and then square root 1 is just 1, right? So they just basically interchanged. It looks like it interchanged, right? But remember, our form that we're supposed to write it in was a plus square root b. That's what this is equal to, squared. So a plus b squared is equal to 6 plus 2 squared 5. So we know a in this case would be square root 5 plus square root 1, which is 1. Now in this case, we have a is 1 and then b is 5, so that's square root 5. It's just 1 plus square root of 5. So in both cases should be the same thing. So you can usually use any case, usually when you do something like this. So a plus square root of b is 1 plus square root of 5. Okay, 1 plus square root of 5. Which you could check to see if it's true, because that's 1 plus 5, that's 6, and then 2 square root of 5, right? So that's equal to this. So we know that's true. So that means 6 plus 2 square root of 5, taking the square root of that is 1 plus square root of 5 over 2. And that should be equal to our k plus w squared p over q. So we know k is 1, w is 1, p is 5, and q is 2. So adding that all up together, we get an answer of 9. So that's your answer for 14. Just a bunch of rewriting. So it's a long question, kind of hard. 15, determine all ordered pairs x, y that are solutions to the equation x squared plus y squared is equal to 10, and y is equal to negative x plus 10. So usually when they give me equations, I like to graph them if I can. So I know the first equation is gonna be a circle, so something like this. And I know the second equation is gonna be a line. So it's gonna be like something like right here. So it's gotta go through 2 points. Usually 2 or 1. So I know that's how the picture's gonna look. Okay, so we have a general sense of how it kind of looks. Let's kind of solve it. So we have x squared plus, we will plug in the y into the y squared, so that's negative 3 plus 10 squared is equal to 10. So that's 9 x squared, so that's 10x squared, because add the x squared. That's negative 30, so negative 60x. That's plus 100, minus that 10 is plus 90. So distribute out the 10, so x squared minus 6x plus 9, 0. So 10 equals x minus 3 squared is equal to 0. So x is equal to 3. Okay, so we know x is equal to 3. So we plug in 3 into, let's say, the linear function, right? So that's negative 9 plus 10 is equal to 1. So our coordinates are 3, 1, which is the only coordinate, because this has a double root. So in our picture, it was kind of accurate. It's more like this and something like this, where it intersects at only 1 point. So the answer is 3 comma 1. Okay, question 16. When f of x is equal to x to the power 4 plus 3x squared minus 340 is divided by x minus 4, the question is q of x and the remainder is k. Determine the exact value of k. Um, it's pretty simple. All you had to know is something called the remainder theorem. So if it's x minus 4, set that equal to 0, so x is equal to 4. So we know what x is. X is now 4. Now we just plug in 4 into the equation. So 4 to the power 4 plus 3 times 4 to the power 2 minus 340. And then find that in your calculator. So 4 to the power 4 plus 3 to the power 3 times 4 to the power of 2, and then minus 340, and you get negative 36. So your remainder is k, and that means your answer for 16 is negative 36. Okay. Okay, question 17. A rectangular pool is to be installed in rectangular plot with dimension 50 feet by 70 feet. The sides of the pool are parallel to the sides of the plot land. By code, the pool can take no more than 65% of the surface area of the plot. A walk with equal length from the edge of the pool will fill out the rectangular plot. The owner wants a maximum size pool, and then you have to find the length of the longer side. So basically, let's kind of understand this using a picture. So this is our plot of land, and it's separated by something with a walkway and a pool. So this is our pool, and the other area, like on the side, is the walkway. So basically, since the owner wants a maximum size pool, and that we can't take more than 65%, that means inside this area, the maximum is 65%. That's the maximum we can get. Now, that means basically, let's call this our length, and this is our width, and let's call this x, right? Because it says is equal length, the walkway. Okay, so they're all length x. So what this tells us that is 2x, right? X plus this L is equal to one of the lengths, so that's 50. And x plus one of the other ones, so x 2x plus w plus our width is equal to our 70, our length, right? And since this is 65% of the area, we know what the area is. It's just 50 times 70, so that's 3,500. So 50 times 70, 3,500. And we know that's 65%, so 0.65. So we know that our area for length times width is equal to 2,275. Okay, so if we take the first equation and multiply by negative and then add it to the other one, or you just have the second equation minus the first equation, we know that width minus length is equal to 20. So we know our width is going to be longer because they're both going to be positive, but you can't have a negative length. So that tells us that we need to find the length of the width because that's the longer side, which is what we're looking for in this question. Okay, so we got that. And now all we have to do is that we just have to plug it into our equation. So since we're trying to look for width, let's substitute in for length. So we know our width minus 20 is equal to length. So we can plug that in. So width minus 20 times width is equal to 2275. Okay, so let's kind of delete everything else because we don't need that anymore. We just had this really simple equation to work with. Okay, since the question number 17 says express your answer to four significant digits, that's basically telling me that it's not going to be a nice answer. So you probably just want to use your calculator for that. So we know w squared minus 220w minus 2275. So that's your equation. So all we have to do is just put in the quadratic formula. So w is equal to negative b plus or minus b squared, which is 40, minus 4ac, so minus 4, times a is 1, c is negative 2275, so that minus turns to a plus, over 2a, a is 1, so this is just 2. Okay, so we know that this can't be a minus because this number is going to be greater than this number, right? So you have to be a plus. So plugging into calculator, we could just round. So 400 plus 4 times 2275, take the square root of that, add the 20, and then divide by 2. And you should get an answer of 58.73 for significant digits. So it has to have 4 digits. Okay, and that's your answer, 58.73 for number 17. Number 18, 3x plus 2 is a factor of 5x, 5k to the power 4 plus 13x to the power 3 plus 9x to the power 2 minus 4x minus 4. Determine the exact value of k. So all we need to do is, since this is a x to the power of 4 and this is x, right? That means we're going to be multiplying to a cubic, right? A linear times a cubic is equal to a quadric. So we know 3x plus 2, right? And we know that it's going to be a factor of it. So all we have to do is you can use this idea. I think it's believed to be called the remainder theorem. I'm not exactly sure. So basically 3x plus 2 is equal to 0. Find out what x is, so that's negative 2 over 3. And then you just plug that into your equation. So 5 times k, and then negative 2 over 3 to the power 4, plus 13 times negative 2 over 3 to the power 3, plus 9, negative 2 to the power 3 to the power 2, minus 4 times negative 2 to the power negative 2 over 3, and then minus 4. And that should all equal to 0 if it's a factor. Okay, so let's kind of simplify all the constants first. So that's negative 2 divided by 3 to the power of 3 times a 13, then plus a 9 times negative 2 divided by 3 to the power of 2, and then minus 4 times a negative 2 divided by 3, and then minusing an actual 4. Okay, so we know, let's kind of simplify the first one too. So 2 divided by 3 power of 4 times a 5. So that means 80 over 81 of k plus a negative 32 over 27 is equal to 0. So that means 80 over 81k is equal to 32 over 27. So multiply by 81 over 80. That should count out this number. So k. So this divided by this, that's a 3 on top. This 80 on the bottom, and this is 32. So divide by 4, that's a 20. Divide by 4, that's an 8. Divide by 4 again, that's a 2. Divide by 4, that's a 5. So 3 times 2 is 6. And we have a 5 on the bottom. So our answer for k is 6 over 5, which is number 18. Okay, I mean number 18, right? 6 over 5 is number 18. 19. A infinite geometric series has the first term at 2 and a sum between 5 and 10 exclusive. The possible values for the ratio are represented by the inequality k is less than or equal to r is less than or equal to w. Determine the sum k plus w. So the only way you could answer this basically is that if you know how to find the sum of infinite geometric, the equation is going to be the first term divided by 1 minus the ratio. It's basically just that simple. So our first term is 2, and our ratio is 1 minus r. So we know 2 minus 1 minus r, that's the sum of the infinite geometric series, and it has to be between 5 and 10. So it has to be 5 and 10. And it's inclusive, so it has to be equal to, right? Because it has to include 5 or 10. So all we have to do, multiply both sides by 1 minus r, so that's 5 minus 5r, less than or equal to 2, less than or equal to 10 minus 10r. So we could just focus on this equation. So that means r, uh, that means 5. Oops. That means 3 has to be less than 5r. That means r has to be greater than 3 or 5. So r has to be greater than 3 or 5. Greater than or equal to 3 or 5. Okay, now we can focus on this side. So that means 10r has to be less than or equal to 8. So r has to be less than or equal to 4 over 5. So it's 3 over 5 and 4 over 5. So that's this is our k and this is our w, right? Because r has to be between these two numbers. So we just had to add both of them. So 3 over 5 plus 4 over 5 is 7 over 5. And that's our answer for number 19. Basically really simple if you know what it is. 20. The sum of the three integers is 172. The product of these three integers is 13,824. The three numbers are in a geometric progression. Okay, so find the largest. So basically, since it's geometric progression, let's use x. So x plus the ratio times an x plus a ratio times that ratio squared times x, because that's a geometric progression. They said the sum is 172. And then they said the product of those three numbers, so x times x is 3, x to the power 3, and r times r squared is x to the power r to the power 3 is equal to 13,824. That means Rx, because you just take the cube root. So take the cube root of 13,824, and you get 24. So we know Rx is equal to 24. So we just plug this in. So x plus 24. Let's make the other one 24 also, because this is the same thing as saying R times Rx, right? So Rx is 24, so 24. And R is just, if you rewrite this, it's just 24 over x is equal to R. So it's 24 times 24, which is 256, I believe. I mean 276. So that's 276. I mean 576. Sorry about that. 576 over x is equal to 172. So we know that is true. Delete. Let's move this up. Because now we just have to find x. So subtract 24 from both sides. You should get 148, I believe. 672, yep. And then multiply x by both sides. So that is plus 576 equals 148x. So x squared minus 148x plus 576 is equal to 0. And then you could just complete the square. Oops, 74. So 74 times 74, and then minus 5, 7, 6. So this one is a minus 49, right? So taking the square root of that, that's 70. So 70 plus 7 plus 74 is equal to 144. So x is equal to 144, right? Because x cannot be a negative number. So x cannot be, actually, if x is equal to 4, or x is equal to 4, okay? Sorry, never mind. So x is equal to 4 or 144, okay? So x is equal to 4, and x equals 144, right? So remember, our ratio was equal, I mean, our Rx that we found out earlier was equal to 24, right? So that means our ratio here is equal to 6. And our ratio here, that'll be 24 divided by 144 is equal to 1 over 6. So it doesn't matter which case it is. It's basically running forwards or backwards. So that x is our first term, so 4. So our second term is 6 times 4 is 24. And then 24 times 6 is 144. Right? Or if you're using this sequence, 144 divided by 6 is 24, divided by 6 is 4, right? It's just reverse order, but it's basically the same thing because the product should be the same because they're the same three numbers, and the sum should be the same because they're the exact same three numbers, right? So the largest of the three numbers is 144, and that should be your answer for 20. And that basically covers everything. Generally, take away from this contest, you might want to know infinite geometric series. Mm, know how to deal with radicals, how to deal with functions inside functions, matrices if you want to know how to learn, if you want to know how to do that, and complex numbers, and basically factors. And that's basically it. Out of all the questions, I think they should all be pretty okay. 14 is kind of a little tricky-ish. 17 also because they're kind of long. But other than that, it's pretty much decent. Well, thanks for watching, and I'll see you at the next math record.